Assalamualaikum. Today we are going to learn about the logarithmic functions, which is an extension from the exponential functions. So we have to know some law of logarithms, right? Suppose we have for the first one, all right, so before we go far, so we call this, all right, let me write this, all right, so we have log ax, so this a is called as the base of the log, all right, so this is the base. Right now, if we have log x of base a, which is equal to m, then we can write, actually we have x which is equal to a to the power of m. We just need to bring a, replace at the place m, and then you bring m upwards. So you have a and then to the power of m, right? So you have x which is equal to a to the power of m. That is the first rule. For the second rule, if you have log xy base a, then you want to break this x and y, so it will become plus. So you'll have log base a of x, so plus with log of y base a, right? Something like this. If you have a division, then you will have a log x of base a. If it divides, so it will be minus log y base a, right? And if you have a power here, x log x to the power of m, then you can bring m to the front here, so we'll have m log of x base a, all right, something like this. And if you have log of 1 over x base a, therefore this is actually equal to log of 1 base a and log of 1 base a minus log of x base a, and we should know that log of 1, all right, so any base, so it will become 0, so 0 minus this one, so this is actually negative log of x base a, all right. So we should bear in mind that we have the rule, if we have log base, no matter what base is it, so if it is 1 here, so it will become 0. Right now, if you want to change the base of the log, right, so the rule number 6 here is very important. So suppose we want to have the log base b, so will be something like log base b will divide with log base b. You write x first because x is at the top here, so we have x at the top here, and a at the bottom here, so a here, something like this. So now you have log base b, x divided by log a base b, something like this, okay. And a log can be base of any any number. If you have a log base a, right, so I have to add another rule here, I'm sorry. Number 7, if you have log base a1, of course 0. If you have number 8, log base a, if you have get the same value here, so you get 1. Log 10 we get 1. Log 100 will become 1, and this a should be a non-zero and non-negative number, all right, so it should be a positive number, positive integer, right, specifically usually, right. So you will have something like, if you have log base 10 of 1, all right, a log base 2 of 4, for example, and you can have a log base e is a number, all right, so log base e, right, of 4, for example, so log base e is usually written as ln of 4, all right. Ln is a log base e, all right. Now let's try to simplify the logarithmic functions using the law of logarithms. Suppose we have to simplify these expressions, right? So what should we do, all right? So suppose we want to write this as a single log, all right, so but this 2 does not have log, all right, so look at this, log base what number, so if it is not given, so means it's actually base 10, right? So usually base 10 we don't write base 10, right? So log base 10, right? So we just put log 10. Why? Because 2 multiplied by 1, 2 multiplied by 1 is actually log 10, right? Because log 10 is 1, so we can write here log 10, right, because log 10 is 1. So now this can be written as a log, right? You have you want to combine these two first, right? So I'll have minus will become divide, so y squared divided by by x, so plus with 2 I want to bring up, so I want 2 to go to these powers, so I'll have a log 10 to the power of 2. I simplify first, so let me simplify this one. So I'll have a log of y square over x, this one plus with the log of 100. And addition of two logs, so we want to combine, so that one will multiply. So we'll have something like y square over x, you multiply with 100. All right, so you simplify this one, this will give you 100 y square divided by x. So this is the simplifying these logarithms as one single log. All right, let's go to example number 2. Suppose we have these logarithm expressions, right? We want to simplify. So firstly, if you have a number here, so we want to bring here, right? So if we don't have, all right, so you bring that, right? So it will be something like a log 100, right? This is actually equal to the power of 1 over 2 minus a log of 4x, and then you minus a log of 3 to the power of 2. Log, okay, 100 to the power of 1 over 2, that one is actually a square root of 100 minus log of 4x, you minus log of 3 to the power of 2 will be 9. A square root of 100 will be 10, right? So minus log of 4x and minus log of 9. Now we want to combine these as a single log, so I'll have something like log, all right? So 10 divided by, because minus would be divide 4x, so that one is divide also, so it will go this at this denominator, so multiply with 9. All right, now you have to simplify this, so you have something like log 10 divided by 36x, and then you simplify this again, you will have a log of you divide with 2, so you have 5 over, I think 18x, so 5 over 18x is the answer, right? So that's it. So now what if we have this one, all right? Suppose we have to solve this, all right? Can we write 10 as the base as the base at 3? We cannot write, because we don't have 3 to the power of 2, we have 9. 3 to the power of 3 will be 27, so we don't have any base 3 will give you 10. So in this case you cannot equate the base, therefore you have to use log. So you have to put log base 10 on the left side, therefore you have to take log base 10 on the right side. You know that log 10, all right, so log 10 base 10 will be 1, so this part will become 1, therefore we have, all right, so I'm gonna put x, because x is the power, we want to solve for x, so I can bring down x log 3, right? So this one is actually 1, so I want to have x, so I have to bring this log 3 to the right side, it will become divide, so 1 divided by log 3. So you can use your calculator and you get the answer for this one, all right? You write your answer, right? So 1 divided by log 3, therefore you have 2.0959. All right, we're done. Okay, let's get to example number 4 here. Suppose we have to solve this log equation, all right? So the strategy is to combine the log. So bear in mind that we have the log base 10 right now. So now we combine the log on the left side. So we have log, the addition of two logs, therefore we want to combine, so it will be multiply. So 50 multiplied by x, so we have log 50x. On the right side, 1 can be written as, because 1 does not have log, so we make it log, so log 10, right? Why log 10? Because we have base 10 now, so we have log x plus with 5, right? Now on the right side is the one that we need to combine, so we want to combine the two logs, so we have something like 10. When we to combine this 10 together with x plus 5, therefore we have to multiply. We multiply with x plus with 5, right? Now we already combined, so we have one log on the left side and one log on the right side. So I want to expand this log first, all right? So I'll have 10x plus with 50. Now I have, kind of one log on the left side and one log on the right side. So please do not cancel like this, all right? I don't want this to see this kind of cancellation. You just need to compare, all right? So this one is actually equal to this. So we have, 50x is equal to 10x plus with 50. This can be done with one condition, that the base of the log should be the same. Therefore, I have 50x minus 10x, I got 50. I got 40x here, therefore I have 50. Therefore x should be 50 divided by 40. I have x, which is 5 over 4. Alright, so we are done with this example 4. Okay, now we have this log equation. So now look at your base log. Base is 5. Alright, so we want to have a log base 5 for 2. Alright, now I'll just write here. Alright, so log base 5 of 2x plus 1, which is equal to log 3 of base 5. Alright, plus with 2, I'm gonna put the log 5 because log 5 is actually 1. Alright, so log 5 is 1. Alright, so you just put it log 5 there. Right, because we want to make every term to have the log base 5. Right, now I want to bring these two to become the power of 5. So we will have something like log base 5 of 2x plus 1. This is equal to, alright, log base 5 of 3 plus with log base 5 of 5 to the power of 2. Alright, because these two has gone to this power. Right, so now I want to combine log because we have one log on the left side but two logs on the right side. Therefore, we have to combine the two logs. To combine the two logs, therefore, we should have something like, alright, so I will have log of base 5 of 2x plus 1. This is actually equal. Now, I'm going to combine the log on the right side. Therefore, I will, because it is an addition here, therefore, we have to multiply. So 3 multiplied with 5 to the power of 2 is 25. Alright. Okay, now we are going to compare, because one log on the right side, one log on the left side, we can compare these. All right, the one in the bracket here, I have a 2x plus 1. This is equal to 3 multiplied by 25, you get a 75. Now you have 2x, which is 75 minus 1, therefore 2x, which is equal, 75 minus 1 will give you a 74. Therefore, you want to find x, you just need to divide 74 with 2. Therefore, you get x, which is given by 37. Right. Now, let's proceed with the example 6 here. What if we have something like this? All right. We want to have, all right, but bear in mind that this is log base x, but this one is log base 5. So you have to change to, I think the easiest one is log base 5. Right, so now I have something like log. Right, this one you want to change to log base 5. Therefore, you write first log base 5, log base 5. Right, because this is the rule. You write 5, the one at the top here, and x at the bottom here. So x here. Right, so you are done with the conversion of the base for the log. So you have log base 5 of x here. Now you can actually multiply log base 5 of x to the right side. So this will give you 9 log base 5 of 5. Right, bear in mind that log base 5 of 5 is actually 1. All right, so 1. All right, or okay, maybe I just need to simplify first. So 9 1 over a log base 5 of x. So this is equal to log base 5 of x, and then only I want to bring these to the right side. Therefore, I have 9, which is equal to a log base 5 of x. All right, you square it. All right, to find this, all right, so therefore you have log base 5 of x. So this one is square, which is equal to 9. Therefore, to find log base 5 of x, all right, so it should be what do we call? A square root of 9. All right, a square root of 9. Right, so square root of 9, but you have to have a plus minus here. All right, a log base 5 of x, okay, is given by a plus minus 3, because you take square root, right, for this one, plus minus 3. So how do I make you want to have x, all right, as the subject? So I just need to bring this. All right, there are many methods of doing this. All right, you can take, all right, suppose let me write it here. Log base 5 of x equal to positive 3. Another one, a log base 5 of x will be equal to a negative 3. All right, so if you want to make as what do we call it, x as the subject, therefore you have to take 5 to the power of log 5x. Okay, therefore this one will become 5 to the power of 3. Right, you make both sides of the equation as the power. All right, so this one will give you x by using the rule. All right, I forgot, because you have another rule. All right, let me write another rule here. If you have, for example, number 9, if you have a to the power of log a of x, therefore this will give you x. All right, a to the power of log a of x will give you x. Okay, now in this case, therefore you'll have 5 to the power of 3, I guess 125. All right, another one. All right, suppose this one is using the rule. All right, if I don't want to use the rules, I just move this 5 and this will go up. All right, so it will be something like x is equal to 5 to the power of -3. All right, now I have x, which is given by 1 over 5 to the power of 3. So x is actually 1 over 125. So we have two answers here in this case. All right. Okay, now we have this one. All right. So for the first one, we want to make the log. All right. We should analyze that this is log base 3, but this one is log base x plus 1. Therefore, I want to make it log base 3. So I have to change the base for this log. Right, so I have something like log base 3 of x plus 1. This is equal to 4. All right, so I want to change the log for this one. So this will give you, right, all right, so it gives, right, let me just use log base 3 divided by log base 3. Right, so you just need to write 3 at the top here. All right, so 3 here. And at the bottom here should be x plus 1. So x plus 1 in the bracket. Right, so you have something like this. Okay, now you try to simplify this. You have log of x plus 1 base 3 on the left side. Therefore, log base 3 will become 1. All right, by using the rule of log. So this one is actually 4 over log base of 3 of x plus 1. All right. I want to bring this to the left side. I'll multiply this. What will happen? This will give us log base 3 of x plus 1. This is actually a square because you multiply the same thing here. This is actually given by 4. So to find the to remove that square, you have to find the square root. So you'll have a log base 3 of x plus 1. This will give us a plus minus a square root of 4. This is actually equal to log base 3 of x plus 1. This is actually equal to plus minus 2. Therefore, we need to solve this. All right. So first equation. All right. We have a log. We have a log base 3 of x plus 1, which is equal to a positive 2. Another one, we have a log base 3 of x plus 1 is equal to a negative 2. Right. So we have to solve this one by one. Therefore, for the first case, right, I just need to bring this 3, you bring it here, and then 2 will become power. Therefore, I'll have x plus 1 is equal to 3 to the power of 2. Another one, you'll have, okay, you have something like this. You bring this as a power, so you have x plus 1 is equal to 3 to the power of negative 2. Right now, I have x equal to 3 to the power of 2, which is 9 minus 1. Therefore, x is equal to 8. Another answer will be x equal to, that one is actually 1 over 3 to the power of 2, which is 1 over 9 minus 1. Therefore, I will have negative, all right, and negative 8, negative 8 over 9, all right, negative 8 over 9. Okay, so we have two answers in this case, right? Now, yes, 1 minus and negative 1 over 9. All right, now, what if we have this type of equations? All right, so we have log base 2 and log base 4 because we have for the log base 2, two terms with log base 2, but only one term with log base 4. Therefore, we need to change this log base 4 into log base 2. So we have log base 2 of y plus with, all right, now I'm going to change this into log base 2 divide with log base 2, all right, and then you have to minus log base 2 of 2y, which is equal to 0. Right, so this should be, all right, so the one at the top and this one should be at the bottom here. All right, now you should know that, all right, so we need to simplify this. All right, log base 2y plus with, all right, so log base 2 of y, you divide with, all right, so this is actually log base 2 of 2 to the power of 2, right? So minus log base 2 of 2y, this gives us 0. Right, now I have, all right, a log base 2 of y plus with what do we call this, all right, log base 2 of y over, all right, if you bring 2 to the front here, all right, so this will give you us 2 log base 2 2, but you know that log base 2 2 is actually 1, therefore you just have 2 at the denominator. All right, so this one I can separate it. All right, so let me just make it log base 2 2 plus with log base 2 of y. All right, because this is a multiplication, therefore we can separate it to become an addition of 2 logs. So now this one equal to 0. I need to simplify this one, so I have log base 2y plus with half of log base 2y, and then you minus what we call this as log base 2 2 is actually 1. All right, so minus 1, you minus log base 2y. All right, this is equal to 0. Bear in mind that log base, you have log base 2y minus log base 2y will become 0, so you are just left with this part. So now you have a half of log base 2y, which is equal to minus 1, which is equal to 0, so I bring a negative 1 to the right side. All right, let me just write minus 1 equal to 0, and half of what we call y, which is equal to 1. Now I want to multiply this half to the right side. I have a log base 2 of y, which is equal to a positive 2. So now I want to have y as the subject. I have to bring these 2 to bring here, and this will become a power. Therefore I have y, which is equal to 2 to the power of 2. Then it is equal to 4. So that's the answer for this case. All right, so y equal to 4. Right, now let's proceed with the example number 9 here. All right, if you have this type of equation, so in this case you just need to put what we call a log base 4. All right, for this part, so I have a half a log base 4 plus with the that one will become log base 4 of 2x minus 3. This one will become square because I bring this power on this power at the top there. All right, so this will become a log base 4 of 8x squared. Right, now I want to bring this power on top of 4, therefore I have a log base 4 to the power of half. 4 to the power of half means the square root of 4. That one will plus with log base 4. Right, this one I remain as 2x minus 3 squared. All right, this is actually equal to log base 4 8x squared. Right, now I want to make this one. All right, so this is actually a log base 4. Let me just write 2 plus a log base 4. All right, 2x minus 3 squared. All right, this is equal to the log base 4 8x squared. Right, if I want to what we call combine the two logs on the left side, therefore I have to multiply the 2 together with 2x minus 3 square here. Right, so this is something like this, and this is equal to the log base 4 8x square on the right side. Now just need to compare this part. Right, so I will have a 2x minus 3 squared. So I want to expand that one. It will give us 4x squared minus 12x plus with 9. Alright, this part will become equal to 8x squared. Alright, now I expand this. I'll give us 8x squared minus 24x, right? Because 4 with yes, alright. Plus with 18, this one will equal to 8x squared. So I have 8x squared on the left and the right side, therefore I can eliminate this, right? This will become 0. Or you know, kind of you bring this 8x squared on the right side, right? If you can see this, it will become something like this. Negative 24x plus with 18 is equal to 8x squared minus 8x squared. This is something like this. So we have a negative 24x plus with 18, this one equal to 0. Therefore 24x is actually equal to 18. So x is equal to 18 divided by 24. You can use, you divide with 3, therefore you have 6 over, what do you call? Divide with 3, right? 6 over 8. Okay, again you can divide with 2, so you have 3 over 4, right? X is 3 over 4 in a simplified form. Okay, that's it. Thank you for watching this video.